I thank you for your kind introduction. Hello everybody. Good morning and good evening. Today I would like to talk about the recent activities or social movement in Japan regarding the concrete sector toward carbon neutral society. So as for background, the first one is about CO2 emission from Japan. So based on our statistical data on the industry in Japan, the total CO2 emission was about 1,190 megaton per year at 2017. And a cement production process produced 53 megaton per year, which is corresponding to 4.5% of the total CO2 emission from Japan. And concrete production process produced 7 megaton per year. And regarding the cement production process, about the 15% emission was due to calcination, and the rest was by combustion, electronic, and transport. So thus, the CO2 emission due to calcination was 26.4 megaton per year, while the maximum value of 44.2 megaton per year was confirmed at 1996. And industries relating the buildings produced about 36% of the total CO2. And this is the detail of this number. And the 11% of the total CO2 came from the construction process. So as it is generally recognized that the running energy has a large impact on a CO2 emission rather than the construction process, but still this number cannot be ignored. So we have to think about the CO2 reduction in a construction process. With regard to environmental load, 1,590 megaton per year was consumed in 2017, and the construction sector consumed about 42% of the total resources. So when we look at the more detailed numbers shown here, we can see that the concrete sector consumed about 12% of the total resources, which is about 200 megaton per year, and this number is almost double of the steel consumption. So then, I would like to introduce the history of social consensus toward carbon neutral society in Japan. Architecture Institute of Japan and other four professional institutions has published the vision 2050 building related measures to counteract global warming towards carbon neutralization at 2009. And in this vision, they decided to promote the minimization of CO2 from buildings during the next 10 to 20 years through the carbon neutralization of new construction, and promotes the carbon neutralization of all buildings related sector, including existing building by the year 2050, and promote carbon neutralization of the surrounding city, region, and society. And 1 year later, Japan Society for Civil Engineers published the urgent recommendations about the environmental issues. So they recommended 4 implementation measures. They are research and development to reduce CO2 emissions, and inducement measures to balance the environment and the economy. So reduction of CO2 emissions from national land planning and the transportation planning. The reducing CO2 emissions in the construction sector by material development and better life cycle CO2 design, and overseas support for global warming mitigation technologies. Japan Concrete Institute and other concrete-related institutions published the Concrete Sustainability Declaration at 2012. In this declaration, there are 8 actions are proposed, and they declare to promote the sound concrete structure for sustainability of society and the reduction of CO2 emission and resources for concrete structures, resource recycling, and biological and local environment conservation and improvement. So It should be noted that this declaration is after the Fukushima Daiichi accident and the Tohoku large earthquake. And for this background, we change our society bit by bit by applying laws and new systems. So I would like to introduce major decision of our society. First one is Low Carbon City Promotion Act, which was implemented 2012. This law is designated to establish a recognition system for low carbon buildings that contribute to the reduction of CO2 in cities, and to give preferential treatment to the buildings of high performance evaluation through incentives such as tax reductions. So local government is required to make a low carbon city development plan, and the government gives financial support to the local government which aims for compact energy efficient city. So for this law, low carbon building certification system was developed. Then afterwards, AIJ, Architecture Institute of Japan, published the AIJ Action Proposal 2015. So in this action proposal, from our construction material perspectives, these are emphasized. So circular use of the resources, the reduction of resource consumptions, and the conversion to low LCCO2 materials, and expands the life of material use and building life, and the utilization of natural materials. So this carbon neutral roadmap, the building carbon neutral should be attained until 2030 as a specific leading buildings. And this action proposal is trying to change all the existing building as a carbon neutral building until 2050. So this figure is historical changes, showing the historical changes of the greenhouse gas reduction target decided by our government. So in general, as time goes on, the target become more challenging. So previously in 2016, as the year of the 250, 80% reduction of CO2 from a reference year of the 2013 was set. And then the net zero is decided at the October 2020. So now we are moving to 46% reduction at 2030 from a reference year of the 2013. And in the cabinet decision at the 18th June 2021, this is a really big event for us. So an action plan of the growth strategy was shown. And in the chapter 3, section 3, item 4, there is a reference to material industry and the industry relating to carbon recycling. And in this part, I pick up the words directly. So carbon recycling is a technology that effectively utilizes CO2 as a resource and is an important cross-cutting field for the realization of carbon neutral society. Japan has a competitive edge and aims to develop this technology globally after reducing costs and promoting social implementation. And there is also about some reference to the concrete. So specifically, CO2 absorbing concrete is targeted to be available at the same price as the existing concrete by 2030 through increased demand and new products with anti-corrosion performance reinforcements or building system which is not affected by such problems are targeted to be developed to be available for building applications by 2050. And at the same time, simultaneously, the green growth strategy through achieving carbon neutrality in 2050 formulated by a Ministry of Economy, Trade and Industry at the same day. So this strategy covers all the industrial fields, and of course, concrete sector is also mentioned. Actually, this is a key action of our government, which changes our society dramatically. So in this strategy, the government says that by using the chance of a public procurement, the CO2 absorbing concrete and the similar materials will be emphasized to create demand and reduce prices. And also, they back up such development to utilize the Osaka Expo, which will be held in 2025 to demonstrate the performance of CO2 absorbing concrete and accelerate the performance improvement of such materials. And this is an execution plans in the strategy where the following targets and goals are introduced. So as I mentioned, the cost target of CO2 absorbing concrete is the same price as existing concrete in 2030, and expand the sales channels to Asia through international standardization, the PR, at large international exhibitions, and develop and demonstrate anti-corrosion steel or other alternatives to expand application to buildings and concrete blocks. The establishment of manufacturing technology for CO2 absorbing concrete that can be adapted to regional characteristics. So those are mentioned in the strategy. So this figure shows the schematics of a concrete life relating to calcium and CO2. In the clinker production, the calcination is concerned. So the CO2 minimization and also CO2 capturing technology is quite important here. And the clinker is ground to make the cement, and by using the other materials, we make concrete. And from the mixing process, we can apply the CO2 fixation. So it is very important there is a quite big challenge to maximize the CO2 fixation without deteriorating the property of concrete. And at the end of the concrete life or concrete structure life, we also have to think about the crushing process and also demolish the concrete. So as you see, as you know, after the crushing, due to the increase in the surface area, large CO2 fixation is occurring in this period. And for the reusing these kind of materials, bottoming or recycling or aggregate are also very important the research target. So application or expansion of application of these materials are also very important. And at the same time, waste, which contains calcium, is quite important. So such as blast furnace slag or residual or returning concrete, they have plenty of the calcium oxide inside. So the technique to extract the CaO from such material is quite important. Especially the cost reduction, energy reduction, and efficient CO2 fixation. CaO extraction is important here. And if the calcium carbonate is quite useful or easy to implement the previous industry the processing, in this case, the efficient calcium carbonate process is quite important. At this stage, also the cost reduction and the new supply chain is quite important. So since, as you know, from the material science, from a material science point of view, the calcium is a key element because it is easy to make the low density hydrate, which efficiently fills the material inside and easy to get hardened. So, so efficient calcium cycle should be established in a concrete sector. So these are the list of the national projects in Japan since 2012. So the green color represents the CO2 capture from cement factory. So there are two projects running now. And the orange color shows the CO2 absorbing concrete. So there are 1, 2, 3, 4 projects are running. And the blue shows the calcium recycling from waste. And others are CO2 recycling system. So they are started from the last year or this year. So many big national projects are running at this moment. And then I would like to introduce some example of the concrete which can capture the CO2 inside. So this is an example of the concrete called the TE concrete developed by the Taisei Corporation. So this target is exhaust CO2 gas from the industry. They capture this kind of CO2 as a calcium carbonate and make the fines and aggregate can be used in a concrete. And this is the concrete called the CO2 Suicom developed by our Kajima Denka Tube Electric company. The most important material is gamma sheets S. The gamma sheets S is a calcium silicate, but which can react is the CO2 gas, not the water, to produce the calcium carbonate and the silica gel inside. So if we replace the ordinary Portland cement by this gamma sheets S, so there is the CO2 reduction by replacement. And also they can react with the CO2 under the general temperature and capture the CO2. So therefore, it is possible to attain the carbon negative from the ordinary concrete. So these two concrete is quite close to the real application. This is more the fundamental one. This is the concrete. This is the calcium carbonate concrete, which binder is calcium carbonate. So by using the demolished concrete, the aggregate is reused for the aggregate of this calcium carbonate concrete. And also the calcium resource is extracted from the concrete waste and capture the CO2 to make the bicarbonate solution and try to precipitate the calcium carbonate between the particles to bind this kind of the concrete waste. So this is an example of the calcium carbonate and the concrete. So this is still development phase in the project called the C4S project, which led by the Professor Takafumi Noguchi from the University of Tokyo. And this is the other research activities. So you know, for this kind of material, the standardization is quite important. So the methods for CO2 fixation and concrete are under developing, and I'm leading this project. Let's summarize and conclude my presentation. So the calcium is a key material for construction. So because we extract the calcium by producing a CO2 from the limestone, and this calcium is quite efficient because it is easy to make the low density and hydrates, which can contribute very much to development of the concrete strengths. So we have to think about the circular calcium system in the concrete sector. So Japan government encourages developments and implementations of this kind of technique into concrete sector of both domestic and overseas societies. So large number of trials has launched, started in Japan, and the knowledge exchange and the collaboration between ACI and JCI could contribute to the better future. Thank you very much for your attention.
Thank you very much, Professor Maruyama.